All right, so just to finish this out here, got cut off on that last one, but to finish this out, line C, which one looks like it's perpendicular to line C? We look at that line C, the which line looks like it's perpendicular, and hopefully you're seeing that line C right here, line C, looks like it is perpendicular to the purple line, So hopefully you're seeing line C and the purple line are um, perpendicular to each other. So line C was y equals negative 3x minus 2. Let's write that down. Our purple line is perpendicular. And the equation there was, so line C was y equals negative 3x minus 2, I believe it was. And that was perpendicular to the purple line. And the purple line's equation was y equals 1/3 x. Let's see, 1/3 x, what was it? Plus 7. 1/3 x plus 7. Okay, so 1/3 x plus 7. So here's what's so important about this whole process. I know it's a lot of information, but it is so important to compare these equations to each other. Okay, you got to compare them. So we're going to be comparing these two equations to one another, these two equations to one another, and these two equations to one another. So important to be able to compare those. So how are we going to compare them? The question is, what do you notice about the slopes? Once again, the question is, what do you notice about the slopes of each function? So if we come back and we look at the slopes of each one, the slope of this one was negative 2/5. The slope of this one was 5/2. Slope of this one was 2/3. This one was negative 3/2. Negative 3, positive 1/3. So you might not be noticing this one as easily. Our last class, what you noticed was that all the slopes were the same. And that was our conclusion, that perpendicular lines have the same slope. Perpendicular lines definitely do not. Parallel lines do, but perpendicular lines do not have the same slope. So let's just take the first one here as an example. So the first one, we're going to compare them. The first one was negative 2/5 versus, if we compare that to the other one, its pair was positive 5/2. So what I'm hoping you're noticing here, okay, is that not only are they very different, there's a pattern. And the pattern is that one of them is negative and the other one is positive. So we don't have the plus sign there, but it really is. So negative 2/5 and positive 5/2. That's always going to be the case. That one's going to be negative and one's going to be positive. They have to be different signs. Okay? So that's our first observation. Observation number one is that one's going to be negative and one is going to be positive. Okay? The second observation is that if we were to take the 2/5 and flip it, the 2 goes to the bottom and the 5 comes to the top. So really what's happening here is we are flipping the fraction as well. That's not the mathematical term for it, so I'll put it in quotes, but we are flipping the fraction. You're going to flip the fraction. So that's kind of our two observations. That happens again and again. We can look back here again. Positive 2/3 right there. Positive 2/3. That one's positive. Negative 3/2. That one's negative. And 2/3 flips to 3/2. So once again, they're opposite. One's positive, one's negative, and then their fraction flips. Same thing happens for our last pair. Let's now compare the y-intercepts because it asks us to compare as well the y-intercepts. And this is not actually that important. I'm just hoping you're going to see that they are all different. None of them have the same y-intercept. But even if they do, it doesn't matter. Honestly, it doesn't matter. It happens to be that they're all different, but they're actually allowed to be the same. Okay? So the y-intercepts are allowed to be the same. It actually doesn't matter. The y-intercept can actually be whatever it wants. Okay, it can be anything, no problem. And it can still be perpendicular. Okay, so how do we summarize this? How do we summarize this about the slopes and the y-intercepts? Our summary is this. Our summary is, this is the big one right here, this top one. Our summary is that in order to put this into words, if one is going to be negative and one is going to be positive, the the word for that is that they have to be opposite signs. Opposite signs. They're going to be opposites. So opposite signs. One's got to be negative and one's got to be positive. And then, like I said, flip isn't the mathematical word. The correct word for that flip part is they are called reciprocals. Okay, reciprocals. So any slope that is perpendicular must be two things. It must be opposite from its perpendicular slope, and it must be the reciprocal of its perpendicular slope. The reciprocal is just the mathematical way of saying that the fraction is flipped. Okay, so that's our first observation, opposite reciprocals. Our second observation is really that the y-intercept can be anything it wants to be. There's no requirement there. Nothing wrong with it being the same or different. It can be anything. So that's our big takeaway for today, is making sure that we can deduce that perpendicular lines have opposite reciprocal slopes and their y-intercepts can be anything. So hopefully that's starting to click for you. Let's keep practicing, and as we did last class, start to see how we can create equations that are perpendicular to each other.